Music in Motion, our final year 4 OI6 design project. The purpose of this project is to challenge ourselves what we learned during our university experience. Why we chose this project? Because we wanted it to be fun and not overwhelming and engaging for all our group members. We come from the same electrical and computer divisions. We use various languages such as C, C#, VHDL.
Now we're going to talk about the architecture of our project. The main components are the sensor, the FPGA board, and the computer, along with the speakers. The way it works is the sensors send data to the FPGA. The FPGA computes the distance in centimeters and sends it over the serial port to the computer. So you can see the distance being read right here. So as I change my hand, it not only plays music but it shows us the distance. We used a software package called Quartus to implement our hardware in VHDL. We used the SOPC Builder, which is another software package, to construct our CPU and the hardware that was needed. We used the NIOS 2 software package to write down the instructions needed for the microcontroller, and these instructions are saved on the onboard memory created by the VHDL. We also send the information of the serial port over to C.
Once the data comes from the serial port, we use C# to get the data from the serial port, and based on the range that the hand moves over the sensor, based on that range we play a piano note. And we are using this. We are using C#. It's a very easy software package. And
why did we choose this over, say, C or other programming languages?
This is for serial communication. It's very easy to use this software. Also, using C# we can get the use of the software packages on Windows. So we are actually for playing the notes, we are using the Windows Media Player of the computer itself to play the songs for us.
So here in Music in Motion, we have designed our intervals to be 9 intervals at 5 centimeters each. So ranging between 25 centimeters to 7 centimeters. Every 5 centimeters will increment will play different sounds. And as you can see here. Another thing to note is that we measure the distance from the sensor every 10 times every second. So therefore you get a smooth music sound playing.
Alright, so all of our group members are going to go through the final demo here, showing the different instruments that we've implemented.
Now I'm going to do demonstration for piano.
Alright, this instrument that we're going to demo is the orchestra with strings. So these are the demonstration for Music in Motion. This instrument that we are playing is piano.
And here's a demonstration for a synthesizer. Here's a little note. it fades out slowly. Here's a high note.
Too high.
And here's the combined. And it slowly fades out again. And here's the presentation.
Okay, now that you guys seen a demonstration, we wanted to talk about things that we could improve next time. One of the things is the sensitivity of the sensor itself. While we have levels which are increments of 5, sometimes it has an error reading it. So the motion is not as fluid as it could be. So you have sometimes it reads too because the data that it senses isn't accurate. So we would use a laser sensor instead of a sonar sensor to get it more accurate. We would also like to create multiple instruments that can be played at once. So have one sensor that is the drums, one sensor that's the piano, and so forth, and you could choose different combinations between them. Another thing we could implement is that when you play a beat, it stays on for a certain few seconds before it fades out, creating a different effect. So there's a lot that could be done and improved with this project, but if we had more time and more resources, we'd definitely implement that. But that is a recommendation that we leave to maybe the next class who wishes to improve on our design. Thank you very much.
So guys, what do you think about the project?
Excellent.